So in this first lesson, we are going to look at the requirement of a different programming paradigm. So we've been seeing so far, for example, in the case of a Python program, there are if-else conditions. There are instructions after instructions, conditionally executed. That's what normal programs work. But these programs cannot do certain things. It cannot do image recognition. It cannot do speech-to-text translation. Our human brain doesn't work in a if-else condition. That is the kind of intuition we are trying to achieve in this particular lesson. Now, without further introduction, let's get into the topic. Why do we need AI? Why do we need a different programming paradigm? Why do we need a computing paradigm, different computing paradigm? That's what we are trying to get at. So we are going to revisit a couple of prerequisites for this training, mainly from the Python programming course and the basic computer science course, mainly to understand what are the limitations of these programs, what it cannot do. So the computer is made of mainly 3-4 components. One is the CPU, or the chip, which is doing all the calculations, all the instructions. And then the computer memory, which stores data which cannot fit into the CPU. And then there is different devices like disk, then the graphics card, then the monitor. All these different devices are controlled by the CPU with the help of memory and other programs. The main program which controls all these different hardware devices, mouse, keyboard, graphics card, NIC card, the main software it controls is called the operating system. So we have seen different variants of operating system: Linux, Windows, Mac, Android, which is a variant of Linux. Different operating system. They are nothing but software which is controlling different hardware. So this is the hardware and this is the software. So this is the overall setup we are having. Now, the operating system cannot do everything. That's where we need additional programs which runs on top of the operating system. So these are additional programs. This can be developed in different programming language like Python, Java, C++, C# and whatnot, Golang, Rust, all different programming languages. Examples of traditional programs are like Notepad, Word, Excel, Chrome browser, all are traditional type of programs. We have seen a lot of details in multiple different trainings. Now, we have also seen these programs. In the Python training, we have seen so many programs. For example, programs to calculate the highest number among a list of integers. We have seen that program, for example. So let me get a little bit into those details. I'm going to erase this diagram and going to the next. So we are going to talk about traditional programs. When I say traditional programs, I mean programs which are not AI or created using neural networks or anything AI related. The fundamental property of these programs are basically consist of if-else conditions. So all the programs does pretty much read and write from the memory, read and write. If-else, then loops. Pretty much this is what all programming language does. They check some condition in the if-else kind of construct. Then based on that, it read or write to memory or disk or some other device. And then repeat the process until something happens, until the data is done. So almost all the programs works like that. Word, Excel, PowerPoint, Chrome browser, everything works like this. In fact, all of them can be created using simple gates. We have seen that in our basics computer science training. For example, a NAND gate. The NAND gate itself is a very simple gate which can create any other gate, which means it can create any program in the traditional sense. We have seen all this detail. So if you remember the input and output of NAND, A and B are the input and output is O. NAND gate is the opposite of AND gate. So 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0. That is the truth table of a NAND gate. Very deceivingly simple truth table we're having here. But we have seen how this simple table creates the entire digital world by using these ideas. Now, what are the limitations of this particular approach? Certain things we can't do with this if-else approach. I would like to categorize that with a general type of program or general type of requirement called pattern recognition. Those are simple things we do in our daily life without even caring about it. For example, when we see a familiar face of a person, we recognize that pattern immediately. For example, when we see our colleagues, our family members, friends, it's all patterns, our eyes recognizing, the brain recognizing from the signals eyes are providing. But if you try to write such a program using if-else condition, you will know that it is super hard. It is next to impossible. So one of the reasons is that there are so many different types of input. For example, if you consider a face recognition program, there'll be so many different permutations and combinations to consider to write this kind of program. The program gets too big. So this approach is not going to work for pattern recognition programs like face recognition, voice recognition, natural language processing, NLP, all that kind of stuff. So for that kind of requirements, there is a slightly different approach has been taken. And that's what we are going to discuss next. Basically, neural networks and related concepts. So we have seen some of the scenarios in which the if-else conditions doesn't work. The traditional programming paradigm, the traditional way something like an application works, like Google Maps or your Gmail or a calculator or a game or anything which is not AI based, not neural network based, not deep learning based, they cannot solve certain types of problems. We have seen that. Now, what is next? How can we solve these problems? That's what we are going to see in the future lessons, or probably throughout this training.